Process and delete. Del. Client polling. Initialize. Message ID. Transaction. Status. Okay. Okay, so trusted is people who have approved users. Untrusted is third-party sources and stuff. I don't know why my computer's so loud. Me. Okay, let me close all this. Okay. Alright. So, untrusted client, API gateway. Client set a request. Lambda, so Lambda. DynamoDB. So response. Res. And virtual private cloud. Packets. These are packets. Route 53. Route 53. And Route 53 sends this. Sends the IP back to CloudFront. So let's call it CloudFront. And CloudFront. Okay. So once we set this, let's send it to the load balancer. It sends that to the gateway. So let's just call it EC2. Okay, so this is the gateway. This is where other this is where virtual private clouds exist. Okay, so we also have over here we have the access control list. And yeah, so step functions, workflow, steps. Step 1, step 2, step 3. All this is workflow. Okay, this is a workflow. This whole thing. It's what step functions do, executing steps. We also have what else? Data processing. So streams of messages and individual messages, which is normal messages. And individual messages, when you click it, when you view it, it's deleted from the queue. The streams of messages are kept for longer. And there's also a let's see, failure management. So let's try catch failure blocks within the code itself. Kinesis. So Kinesis is for complicated apps. The Kinesis streams. Okay, this is for complex apps. So for complex apps, and Kinesis Firehose is for simple apps where you don't need data is not needed, and in this case, data is needed, like analytics and stuff. So this is complicated setup. Okay, simple setup. So this is Kinesis, what's it? Firehose and Kinesis normal streams. Okay. So let's go on to sync and async. So async tries up to sync. If it fails, it fails. Okay. If it's in sync, async is have multiple different functions, operations happening at the same time without impacting the other one. So we wait for certain things to be completed in order to move to the next one. So over here, in each of these, right, in between, if it fails, it's going to be between 0 to 2 retries, okay? And it will give it some time, 0 to 2 retries, and then it will, if it doesn't work, it will send it to the dead letter queues, okay? So messages that, messages as in logs that didn't go through, unsuccessful messages, are pretty much sent back to the dead letter queue, okay? So apart from that, we have error stream-based events. I didn't get back to this. Failed events, SQS, simple queuing system, okay? So we're handling in a simple queuing system, failure steps, dead letter queues, migrating serverless, Fargate. So Fargate is obviously containers, but serverless. So it's like Lambda. So Lambda is for events. So it's a events, and Fargate is for containers, okay? So these containers, these pretty much, so Fargate is for containers and this is for, Lambda is for events. Both are serverless, so it's a serve, no serve, okay, for both of them. So yeah, apart from that we have API, this is Lambda. And this is where S3 comes into play, and CloudFront. So S3 is the one, is the DNS, and then it receives it, and then it sends back to CloudFront. CloudFront pretty much processes, sends it to Lambda. Lambda sends it through a elastic load balancer, which then handles, first CloudFront. CloudFront sends it to a elastic load balancer. Elastic load balancer sends it to Lambda. Lambda processes it, and then it pretty much does the job, and pulls from the DB, DynamoDB, for example. So these are all the different steps. So we have step functions which are working in workflows. So this is the workflow right here, and we have different steps that need to be executed in order. So let's take a image of this. So I'm going to grab this real quick. Let's say, for example, cloud. Let me just WebSockets. Okay, so data processing. Stream that around. Same. So loud. I gotta fix this right away. Okay. Just processing multiple record multiple times. Same record multiple times. So same record, multiple. Ignore this. Okay, ignore that. Multiple times is you don't tempo tendency. Okay. Same record multiple times. Processing it. Processing same record multiple times. Okay. Failed events, SQS, simple queuing system, and Fargate, SNS filtering, so that's a simple notification system, filtering the needed messages and the other, just letting go of the other messages pretty much. So publisher delivers a message to the subscriber, I think, yeah. Publisher just delivers a message to the subject, my bad. So cloud publisher delivers a message to the subject, right? So I mean that's kind of obvious now that I think about it. It's obviously delivering to a subject, right? That's the whole point. Serverless automation. So let's go to concurrency is like the number of Lambda tasks that can execute at the same time. So up to 1,000 different tasks at the same time. And serverless, okay, so predefined, and at a predefined time. There we go. So CloudWatch obviously watches for events and then logs them. You also use the Lambda logging library. So the Lambda logging library sends errors. So all this gathers the errors. So this gathers the errors and then you push it onto CloudWatch logs. So let's call it C-logs. And serverless at scale. So how to scale up the serverless? So it's either Lambda or Fargate. So Fargate for the containerized applications and Lambda for event-driven applications. So as you can see, try managed services provide scaling, security, and accessibility. Okay. I mean managed services. Okay. Cloud managed services provide scalability, security, and what was it? Sustainability, was it? Accessibility, my bad. So you can scale, access, and keep it secure. We also use Cognito. So Cognito is a cloud Cognito for AWS Auth and security, pretty much. That's what we use. And it's for authentication and concurrency, SQS. Scaling Lambda, scaling power tuning is giving certain resources, certain resources more memory. Helps you give more memory to functions. So yeah, allocate memory. So Lambda power tuning allows to allocate memory for functions. Okay, so certain functions obviously need more memory, right? So also caching. So we have Redis cache, which helps in keeping things sort of stored as cache, and then like sort of retrieving it easier. Because when you retrieve it easier, it's obviously much easier to retrieve something. And then so let me just type this out. Redis saves data temporarily for faster load times and less bandwidth consumption. So we have Lambda power tuning, and let's go to. So what I'm gonna do here is a function. What was it? Pretty sure I copied this somewhere. No? Okay. So let's go on to execution speed. So let me just copy this function execution speed. So using execution environments. Increase right. So function execution speed is increased. So function execution speed is increased when you reuse execution environments. Okay, let's move on. Scaling databases. So obviously we have what is this about? Dino? Yeah, it's about Dino. So Dino is obviously keeping everything in key value pairs, but there are so everything sort of Dynamo DB accelerator. So that's what DAX is. So we have normal Dino. So we have normal Dino. So let's just call it Dino, and we have Dynamo DB accelerator. So we call it a DAX for faster performance. So this is for use cases like gaming, for example. Where you need streams of messages exchanged back and forth from the application itself, so it's better for those kind of like these type of applications. Relational databases, so we obviously have things like Dino and what was it? I forgot the name of it. MariaDB. So, right, so we have relational database systems like MariaDB, all Postgres-based, SQL-based databases, and we have DynamoDB, which is more of a MongoDB type of structure, but not really. So MongoDB obviously saves in documents, so key value pairs for everything, with a key for the document itself, and you cannot directly terminate the connection when Lambda environment is destroyed. Pretty sure that's what it is. I don't know. Let's double check. So you can't directly terminate the connection when the Lambda environment is destroyed. Pretty sure that's what it is. Let's see. Okay, there we go. Scaling step function, so it's obviously executing in different steps, and communicates between service, an activity worker communicates between services to receive tasks and perform them. That's what it is. So it's activity worker, right? So it's an activity worker communicates between, okay, service 1, so it's a service 1 and service 2. So what happens here is you pretty much service 2, and what happens here is you communicate between these two. Okay, so you send requests and responses. I get responses back. So it's a activity worker. Okay, so it's a, I don't know, activity. Let's say for example, okay, let's make this more interesting. So this guy is an activity worker. Okay, he's got a hat. Okay, he's got his hat, work hat, and now he's going to communicate between different services. Okay, so it's service 1, service 2. Okay, so it's communicating. So once we communicate, we receive tasks. Okay, so when we communicate with these services, then we receive tasks in turn, and so pretty much this guy, right, the activity worker, this guy then takes these tasks, and then he goes on to perform them, right? So perform functions. Okay, so it performs the functions within them. So pretty much just does it. And scaling Kinesis. So obviously Kinesis is part of data streams and data firehose. Kinesis firehose. Firehose is obviously for smaller applications, and for larger applications you need Kinesis streams. So what happens here is let's see. Right. So for this, a function error, maximum record age, retry attempts, and failure destinations. Okay, so a function error, maximum record age, maximum attempts, and failure destination. So retry attempts. So a function error, maximum number of attempts. No, was it age? Maximum record age, failure attempts, try attempts, failure destinations. So a function error, maximum record age, retry attempts, and failure destinations. So what we're going to do here is a function error, maximum record age, and failure, retry, and failure. So a function error, maximum record age, retry attempts, failure destinations. So let's go on to, I'm going to run through these real quick. Right, usual slogan, build, measure, learn, repeat. Exactly, right here. Serverless securing. So let's go on to, so we have identity access management, of course, Cognito for authentication, and authorizers. So Lambda authorizers, so the difference between Cognito and authorizers, custom auth processes. So Cognito is usual auth, inbuilt auth system. And authorizers love to build custom auth process. Okay, cool. Cognito in identity access management. So this is obviously for access control. The access control list. So you verify and then you let people in to the virtual private cloud. Let's go on to data protection. So encrypt certain types of data. So I don't know why my computer is so loud, but anyways. So for S3, which is a simple storage, DynamoDB for simple applications. So pretty much this is non-relational, right? DynamoDB is part of non-relational. And Aurora is obviously Amazon's better way of doing things for relational databases. Let me double check with that. Aurora is really Amazon's relational best database system, question mark. Yes? Yeah, okay. Yeah. So Aurora is part of so let's say for example Aurora is a SQL relational database part of the AWS ecosystem known as the best within. Okay. So S3 is for simple storage, DynamoDB is for no non-relational data, Elasticache is for Redis type of data, and it decreases load times and it keeps things, it reduces load times, and it also enhances the application because of cache, right? Saves it temporarily. So what can you use to encrypt data? So it would be key management service. Pretty sure that's what the answer is. Let's go on to SL monitoring. So I'm pretty sure you use the CloudWatch and for alerts and stuff. So we see over here we have key management service. So X-ray is simplify and explain what AWS X-ray does, question mark. Right. CloudWatch logs. So pretty much everything is like sort of logged onto as different events, different logs, and you can also CloudWatch logs, and we also have the cloud alerts. So CloudWatch pretty much lets you set different alerts for different resources to make sure it doesn't exceed certain limits. And yes, this is for a gateway execution and access logs. So everything's sort of logged. Performance. What was it? Let me check. Customer user experience metrics. Okay, so customer experience metrics for UI and UX. So customer experience metrics. So it's a cloud customer experience metrics for UI and UX. Okay, so X-ray is obviously performance issues clearly. Helps debug errors in microservices and serverless apps. Works with services like Lambda, API Gateway, and DynamoDB. Think of it as a CT scan, right? Right. So it does everything in terms of what's happening within the application. So it's like an X-ray of the application. So it takes an X-ray. So X-ray. Cool. Apart from that, what else do we have? Let's move on to X-ray demo. So we know what Lambda does. Obviously, it's basically for event-driven architectures, simple application use cases, for example, and they're serverless. So for containerized applications, we need to use Fargate, And for API gateways, obviously we know the request response cycle from the client itself, and then pretty much the API gateway sends the request through the Route 53 DNS service, which is then sent back with the IP to the cloud front, and then the cloud front pretty much sends it to the Elastic load balancer. It balances the load out and filters things out, and then pretty much sends it to Lambda. Lambda processes the request, makes whatever the logic that needs to be done, and then it sends it back as a response. So usually Lambda communicates with Dino for grabbing certain resources, right? So we have Cognito, which is obviously for authentication, and we have SNS, which is a simple notification system, and SQS for simple queuing system. SNS is obviously messages, notifications of messages of the components within the application. So for example, when applications are interacting with each other, it will sort of send messages, right, individual messages. So what SQS does is it adds all of them into a queue, and you can select from this queue, you can process from this queue, you can pick from this queue, and then you can process from the queue, and then you can delete from this queue. Apart from that, we also have asynchronous and synchronous. So synchronous is obviously happening in real time, but it does not wait just in case it fails, and it just moves on to the next thing. But in asynchronous, it's obviously like it even if it fails, it will stay there. It will retry up to 2 times, maximum between 0 and 2 times, and then it will move on to the next thing. If a message is not delivered at all, right, it will send it to a dead message. Dead queue, right? What was it? Dead letter queues, right? So if let's say for example, if messages from the SNS is not delivered after retries, it's sent to the dead letter queue? Question mark? Okay, yeah, it is. So pretty much apart from that, we have samples and instruments incoming, active instrumentation. So let's say, so it samples and instruments incoming requests. It writes traces to X-ray. It can be integrated with Lambda and API gateway. So Lambda is obviously event-driven, and like I said, it's for event-driven purposes, simple applications basically. Whilst Fargate is obviously for containerized applications, which have more complex solutions, right? So apart from that, what else do we have? Okay, so X-ray is obviously a system where you can get a full X-ray of what's happening in the application. CloudWatch is to watch for certain the resources, set certain alerts, and basically monitor different aspects of your application, right? So as you can see, we have a demo of X-ray flow from Lambda function to S3. So S3 is simple storage. It's part of EC2. So EC2 is obviously where the application itself is first, like the infrastructure for servers and stuff are deployed. S3, so EC2 is obviously using servers, so you need to handle the server side of things. But for serverless stuff like Lambda and Fargate, you don't need to handle any of those. You can just deploy the code, and then you can just get it running up and running, easy. So S3 is obviously simple storage, so it's for like simple storage stuff. Instant stores are for things that are like temporary storage, that are like extremely temporary. So for the moment being, when an application needs instant like temporary storage, it will go on instant store. And what else do we have? So CloudTrail is obviously all the logs from the cloud events are going to be logged as trails. All the logs are going to be logged as trails on CloudTrail, and you can set certain configs, custom configs. And you also have CloudFormation, and that's part of infrastructure as code. So we have CloudFormation, which is AWS system, which uses YAML or JSON, and we also have Terraform, which is used for multiple other cloud providers across vast different amounts of cloud providers. And so that's what CloudWatch is. CloudFront is. No. CloudFormation, my bad, sorry. So CloudTrail, and so we have events. So every activation in your AWS account, right? So every action, right. So pretty much, let's say for example, cloud, every action on your account logged as a CloudTrail event. Right, so you can pretty much watch like what's happening within the within CloudTrail itself. So apart from that, it's a configuration that enables logs of what events. What's the definition for this? CloudTrail events. Okay. So let's go on to serverless deployment. So when you deploy on deployment is deploying the application, transferring the current application to a server. So we have transferring the current application to a server. Yep. Developer, so it's obviously for serverless development. So we have local testing, obviously. We have what was it? SAM, which is serverless automation. Serverless. What was it? So we have the CLI and templates. So is configurations. So serverless application deployment module. So let's say, for example, for AWS CloudFormation. So SAM, so Uncle Sam is a serverless application deployment module for CloudFormation. So CloudFormation is obviously for infrastructure as code and for containerizing basically, and orchestrating, right? So like certain scripts for CI/CD pipelines and all that. So that's what we use CloudFormation for. So serverless application deployment module. So what is it? A serverless application deployment module. So who is Sam? Okay, Sam. Okay, this guy is Sam. All right. Let's say I'm just gonna draw like I don't know what that is, but basically this guy's Sam. All right. You know what? I'll draw Uncle Sam. So this guy's got like a hat. Okay. It's got like a hat, and pretty much this is Uncle Sam. All right. He's got, I don't know what the fuck this is, but anyways, Uncle Sam, right, is a serverless, so he doesn't use servers, application, so he uses application, serverless application deployment module. Okay, so serverless application deployment module right here, serverless application deployment module. Okay, so he doesn't use servers and he deploys applications, serverless application development module. Okay, sorry, my bad, sorry. So serverless application development module. So it's like an application development module, but it's serverless. Okay, so Uncle Sam is a serverless application deployment module, development module. I keep fucking up on that. A serverless application development module. 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 So that's what it is. This guy right here is a serverless application development module. Okay, serverless application development module. SAM, serverless application development module. So it's supposed to be a CDM, but it's easier. A serverless application deployment module. Uncle Sam right here. And what else do we have? We have CLIs and templates, obviously. Serverless application deployment module. So that's what this is. Let's move on to the next one. Right. Sorry. Right. So obviously we have environment variables that impact the application. It's a static, so it's a dynamic variable which changes the behavior of your application just by changing the value that's aligned to a certain key, right? So that's what, see right here, dynamically named item that changes the way a program behaves. So right here, and let's go for deployment strategies. all at once, canary. So I think canary is better for watching for certain errors. So if there's certain errors, all at once is obviously faster, but canary and linear are much better when it comes to observing if there's any problems in the deployment, and making sure we fix it beforehand. Observing them while we try to deploy it. So it's much better. So that's what canary is, for example, right here. So what else do we have? So we have the serverless application deployment module, development module. I keep fucking up on that. Development module. He doesn't do any serverless application development module. So Uncle Sam is a serverless application development module. That's what it is. And auto deployment. So we have CI/CD, which is part of the cloud pipeline. So we have cloud formation, and then we have cloud watch, cloud deploy, and yeah, those three mainly. What else other than cloud formation? Code build, code deploy. What else do we have? Okay, I didn't mean it like that. I made it. Okay, so for example, right here, I don't know what's up with this, but let's see. Source build, test, and production phase, right? Serverless application deployment development module, and this source build, test, and okay, right. I mean, this is the usual life cycle. You just build it, test it, you deploy it, right? So you continuously integrate. So this is what happens over and over again. So we have the source, we have the build phase, we have the test phase, and we have the production phase. So we build it, we build the application, and test the application, and then we send it to production. Serverless application development module, serverless application dev module. So apart from that, we have code pipeline. So we have code pipeline, code commit, code build. So commit is obviously to commit the code. Code build is obviously to build the application, and code pipeline is basically building, testing, and deploying. So it includes automated operations. So code pipeline. So it's a code pipeline builds, tests, and deploys the application. Right, so let's try to link a few unrelated things. So cloud Terraform is obviously for multiple different cloud providers like GCP, AWS, and Azure. And we also have cloud formation, which is for AWS itself, and Terraform is for anything, and any cloud provider. What else do we have? Code pipelines for CI/CD, and it's the whole idea of as the service, and then building it, building it, and then deploying it. Building it, testing it, and then deploying it. Sorry, I got that definition wrong. Procedures and software release procedures, and right. So obviously it checks for, so pretty much when you're deploying an application, when you're committing something, it's when you commit. Before you commit, you obviously build the application, you commit the application, and then you pretty much build the application, and you test the application later on. And then once you test the application, if there's any problem. So before you commit the application, you test the application, you commit the new changes, and then you deploy the final outcome. And that's what a CI/CD pipeline does, and it pretty much checks for any problems in the meantime. So it pretty much checks for any quality problems when you're deploying the actual thing. So for example, that's what this is, and software release procedure. Yeah, so that's what this does. So we have the answer right here. What's that? So we have the answer right here. Right here. So pretty much apart from this, let's go on to serverless application development module. So what we're gonna do here is pretty much look for, this is for CLI, this is for deployment interactive mode. So for example, this is a command which you run to deploy an application. So this is what's been launched when you run this command right here. So pretty much just like logs everything. That's what it is. Interactive mode. Right. So run this command to get interactive for this. So let's say for example, yep, so let's copy, let's put this here. So for example, let me copy this, put this here, copy this part as well. Let me delete this real quick. Okay, so guided is for interactive deployment module, so you can pretty much see what's going on behind the scenes. So you deploy just like that, and let's go on to wrap up. It's not near wrapping up, but right. So event-driven architectures and error handling, application migration. So this is something that I need to look into. So let me just highlight what I need to look into again. I need to look into application migration, scaling serverless applications, securing serverless applications, securing. I think I. Right. Process messages. So pretty much it takes the messages, so all the interactions within Lambda functions and EC2 instances, so it pretty much gets the components, so the communications between the components. It takes those messages, it pretty much adds them to a queue, and then you can pick from the queue, process from the queue, and then delete from the queue. So all of them are sort of what's happening within the application, so different back and forths within the application itself. So logs, in a way. So they're like logs. Question mark? Question mark? Let's see. Right, fundamentally, right, asynchronous messaging process. So the asynchronous, that's the main difference. Are asynchronous and only part of the event-driven architecture provided by Lambda. Okay, so let me just say okay, Lambda. It's easier to remember. Um, function error, maximum record age, retry attempts, failure destinations. Right. Function error, maximum record age, retry attempts, and failure destinations. Right. Okay. Activity worker communicates between services to receive tasks and perform functions. Right. Okay, so right now my head's not all here, so I need to cool down a bit and come back and study this again. I want to finish this off somehow today. Presign URLs assigned to a object, right? So it has access to some object, so it's presign URL. So step presign URL is assigned to some object. So let's say, for example, let me just draw it like, I don't know, like a database like this. So this is a presign URL. It's assigned to this object right here. Okay, so I'm just gonna say obj right here, and then yeah, so it's assigned to this. That's why it's a presign URL right here. So right. Okay. Consumer is like someone who uses Kinesis data streams to perform actions. That's what it is. So producers, I'm assuming, are people who, okay. Producers and consumers. So we have producers and consumers, obviously. So right. So right. So function errors and call errors, we know what function errors and call errors are. So, problems in functions and problems in calling. That's what it is. That's basically for asynchronous events. Asynchronous events obviously, keep retrying up to 2 times maximum. And in worst case scenario, it moves on to the next thing. But it happens alongside other functions, so it doesn't need to disrupt a whole application just because one function is failing. So that's the whole concept. So the API gateway pretty much communicates with Lambda, but there's the load balancer in the middle. And we also have, so there's so let me just draw this. So we have DNS, right? So that's route 53. We'll call it R53. So we send a request, R52 processes it, it sends it back to CloudFormation. I mean, yeah, no, not CloudFormation. What was it? CloudWatch, right? No. 1 second. So let me get this. I fucked up on that architecture. My bad. So we send this request to. We don't directly send it to this. The request packets are sent to route 53, and route 53 sends it to cloud, not formation. I think it was a cloud, not CloudWatch, right? It was CloudFront. CloudFront to load balancer to the EC2 instance, question mark. Right. EC2 instances. Right. Right. Okay. So you send it to the CloudFront caches it, and sometimes uses, I think they use Redis here sometimes, and load balancer obviously to process the request. I mean, bounce things out. Lambda to process it. Once Lambda processes it, Lambda will query databases like Dino or relational databases like MariaDB or Aurora if you're using AWS. And yeah, so pretty much it will like process and then we'll send it back, and then the user will get response cycles back. So that's what it is. For now, I think failure. So obviously CloudWatch logs. So you send the Lambda log. So using the Lambda login library, you publish it to CloudWatch logs. So Lambda log. I think I explained this earlier. So Lambda login library, you publish it to CloudWatch logs. So it says C logs, and you can pretty much you get the errors from here, and then you push it to using the Lambda login library to the CloudWatch logs, which you then observe. So you can observe all the problems. So you can CloudWatch lets you set alerts, right? So it lets you set alerts. It lets you find what sort of logs are happening within the application, and X-ray lets you take an X-ray of the application pretty much, right? So what's happening within different services. You can also use the dashboard and the management console for tracking different resources, and all the limits and stuff are going to be set from this. So that's what this is: alerts, limits. So what else? Yeah. So we have different ways of interacting with the API gateway as well. So it's an API. We have the CLI, which is the command line. We have different ways of interacting with AWS. We have the CLI, we have APIs, API gateways, request response cycles, and also we have what else we have? Yeah, APIs, request response cycles. I mean CLIs, and the dashboard, the web dashboard. That's what it is. Data processing, pre-signed URL. So pre-signed URL is assigned to some object, and so AppSync is GraphQL. So AppSync is a GraphQL service that offers automated real-time data sync. Okay, seems okay for now. API gateway. So in client polling, right? So it's part of Lambda. So pretty much we have a long running transaction. So it's a long running. So if it takes a long time for a transaction, when you initiate it, you get a message ID back. So once you use this message ID, you can pretty much keep calling back to this transaction. So it's a long running transaction, right? This one, so it's a, I don't know, huge transaction like this. So pretty much this message, using this message ID, you can keep calling back and getting status updates on what's happening within this long running transaction. That's what it is. And step functions obviously in Lambda, so it executes in steps. Workflows execute in different steps, and in steps obviously. So event submission, so we have simple queuing service from simple notifications turn to a simple queuing service. It's all part of the asynchronous environment, like event-driven environments, like Lambda, for example. Asynchronous event submission with an SQSQ, right? So you add to the queue, pick from the queue, and then you process from the queue, delete from the queue. So yeah, that's pretty much it. So static queues and FIFO queues. So right. Okay, so there. Okay, so FIFO queue is pretty much guarantee order. That's the difference. FIFO. Fuck. Guarantee. Right. But limited to 300 messages per second. API call. Right. So we have standard, which is unlimited messages, but nothing is properly organized. So it will be super messy in the longer run. So that's the difference here. So that's pretty much it. Thinking serverless. So asynchronous connection. So we obviously know what this is. So right, because it executes stuff simultaneously. So oh my god. Okay, so there we go. So what I'm gonna do here is obviously Hmm. Right. Hmm. Right, okay. Mm-mm-mm. Right, so pretty much everything is processed with one after the other in synchronous, and asynchronous is opposite. So processes all the requests simultaneously, so it's obviously much better. It processes up to 3 times, so 0 to 2, 0, 1, 2, so that's 3 whole attempts. And then if an event is failed, then it will be sent to the data letter queue, and yeah, so it's gonna retry in 7 days of the initial failure. Okay. Right. That's it. For now, I think this is enough. I'll come right back when, right? Cool. Okay. Cool. Cool. Mm-mm-mm. Charge per hour. Charge per request. Okay. So let's say, for example, so load balancer is obviously for managing traffic. This is for receiving requests and responses. And, right, user pools, okay. Okay. Per request, charge per hour. Right, okay, so you use either, okay, so you use either a load balancer or an API gateway. Right, okay. I need to read through this again. There we go. So for now, I'm just gonna stop this here for now, and then I will come back after a while. So Elasticache for Redis, Quantum Ledger database. What? Aurora is obviously a non-relational. Relational database system. That's Amazon's fastest one. And Elasticache for Redis. So obviously it stores data for caching purposes. And so Elasticache is Amazon's Redis. AWS is Redis is Elasticache, making applications load faster and using less resources. So S3 is simple storage, and simple storage is for EC2 instances, and right. Dino, grab this. So I'll go through this part again, and pretty fine. Right. Accessibility, security, and reliability, was it? Scaling, security, and accessibility. I mean, I don't really need to know this, right? API gateway. Burst behavior. Right. So there's 1,000 up to 1,000 requests with concurrency. For example, it will conduct up to 1,000 different requests. When it comes to concurrency, for example, in Lambda, up to 1,000 different events can perform at the same time. Lambda functions, Lambda tasks. So apart from that, we have so concurrency is obviously happening at the same time. And what else do we have? I feel like I'm missing something here. I don't know. I think we should be fine. Customer experience? No, customer satisfaction. Data protection? So this is the key management service. Right. Customer. Right. So simple storage. So this is for simple applications. Like when you want to have like storage for like simple use cases. Yeah. Dino. So this is for encryption keys, right? So you can store it in KMS if you're using Dino. Elasticache for caching, which is basically AWS's Redis, and for AWS KMS, utilizing either manager client. Right. So you can pretty much store stuff in secure cache, KMS pretty much. KMS is a type of caching system. Encryption service, yeah, makes sense. Okay, so I'll go through whatever I learned today. We'll do this again. And you go through these parts again. CloudWatch metrics, CloudWatch logs, Lambda logs, customer satisfaction, what was it? Customer experience metrics. Customer experience, okay. So UI UX should be customer experience. Experience metrics, yeah. So different trails, different logs, logged as trails on CloudTrail. I don't know why my computer's always so loud. Anyways, I'm just gonna go for a bit. I'm going to come back and try to understand what's going on, because my head's not in one place. Speed. Increased, okay. Execution time is decreased, and the speed is increased, right? Execution. Execution environment. My bad. Execution speed. Okay, so what I need to do now is right. Yeah. Right. Right. So if it's something like that's not complex, you can use all at once. You need to use canary. If it's something a little more complex, if it's something extremely complex, then you need to use some linear. So linear is better for more complex. Yeah. Is. Hmm. Right. Okay. Linear canary, all at once linear, and all at once canary and linear.